Hi, Chinmay.
Hey, I'll start sharing my screen. So hello everyone. I hope all of you are doing well and staying safe. Welcome to the session on achieving reliability in a microservices-based environment using observability. I'm your host for the session, and my name is Chinmay Gaikwad. I'm a technical evangelist, as Mohan mentioned, at Epsagon. Please stick around till the end. We have a special offer for you. So a bit about myself. I have had a very interesting journey of having different roles at large companies such as Intel and IBM, as well as smaller startups. My hobbies include traveling, playing soccer, exploring restaurants, and playing video games. These days, it's just restricted to playing video games, though. I'm looking forward to resuming traveling as soon as the COVID situation is over. So let's get started with the session. In this session, we'll look at how microservices have become the new normal and what new challenges have come in the forefront because of this. We will also focus specifically on the challenges in achieving full observability in highly distributed microservices architecture. And lastly, we'll discuss what a good observability solution should look like. So let's start with a bit of context on microservices. As you might know, hand in hand with the evolution of software, there has been a massive shift in the microarchitecture. To over 85% of enterprises are adopting microservices as a default architecture. So we know that more and more applications are cloud rather than being built in data centers or on premises. These applications are very highly distributed, and the application code is broken down into smaller, more lightweight services, which can be almost thought of as mini apps. Each one of them runs independent of each other, so there is no one monolithic bundle of code. Microservices architecture has great benefits, no doubt about that. But the easy to depict architecture diagrams have started to become much more complex, and these have brought about unique challenges. Let's see why enterprises move to microservices in the first place. According to a 2020 report, scalability, speed of development, and decreased system administration are the top. I'm sure most of you and can be done in seconds. It definitely increases your speed of development and allows a lot more efficient utilization of your resources. As we saw, modern applications now have thousands of services with databases, caches, and even more, so reliability has become increasingly complex. Using only traditional monitoring solutions, it can be nearly impossible to know what is going on under the hood. So let's see how we can achieve reliability in such distributed applications. Before we dive into an example, we should start by understanding what observability and monitoring exactly are. Monitoring tells you if a system is working. Observability lets you ask, why is it not working? Observability essentially involves instrumenting systems and applications to collect relevant data. Thus, observability and monitoring are complementary to each other. In my opinion, observability isn't just a tool, it's a must-have culture for any organization. It is important for all, right from the C-suite to the developers. The three pillars of observability are very well known: metrics, logs, and traces. Let's dive into tracing later. Let's start with metrics. Metrics are a great way for operators to figure out if something has gone wrong. For chaos engineering, we know that the four golden signals are latency, traffic, errors, and saturation. Logs, on the other hand, tell us why something went wrong. But when you have hundreds or even thousands of microservices, these alone are not enough. So how does a good observability solution help chaos engineering? Chaos engineering exists so that we don't introduce chaos into our production environments. Tightly coupling chaos experiments with a good observability solution results in higher customer and employee satisfaction, as well as increased focus on innovation instead of fighting unnecessary fights. Observability and chaos engineering should be tightly tied to each other. Let's consider a simplistic example of a virtual shop for this session. Now you want to modernize your application by containerizing it. So as you can see, The HTTP server authenticates requests using auth0, pushes them to a Kafka stream. The Java container pulls the stream and updates the DynamoDB table. Let's say there is a situation where you observe that the orders were sent but not handled. Where would you start? Maybe using traditional APM tools. Traditional monitoring solutions come at the expense of higher resource utilization because of heavyweight and multiple agents. They have the ability to collect only host metrics or are purely metrics driven. So that doesn't really help pinpoint the problem. The very nature of microservices means that this is likely to leave gaps in your observability strategy. Metrics, as we discussed, really only let us know that something has broken, but not where or why. Context is absolutely critical in today's environment. Using the traditional way, first you look at Kafka metrics. You can see that there is nothing much going on here. So then you look at DynamoDB metrics and you can see a few spikes here. That's something interesting. So we need more data to debug. And more data is essentially present in logs. We would look at logs, but they are not really effective for troubleshooting. Let's look at why. We all know what logs look like. Personally, I have a love-hate relationship with logs. Available. Often I found digging through hundreds of thousands to spot that outlier. The exact path a request is taking through indices and components. Logs are good to debug monoliths. They don't really work as a starting point in highly distributed system. So in our virtual shop example, if you're very lucky, you will be able to spot the problem, but it might take a very long time. So let's recap of what are the things that are missing. It essentially boils down to correlation. Correlation between metrics and logs and between different services. The correlation will help us find the exact problem. So how do we correlate these pieces? That is where distributed tracing comes into picture. I am pretty sure most of you might have heard about tracing lately. Many vendors offer some form of distributed tracing. Even service meshes are now building support for it. There are dozens of open source solutions out there as well. However, where did it all begin and why? So distributed tracing was born out of Google over a decade ago, and it allowed engineers to trace a specific path a request makes through services. In effect, it helps shine the light on that needle in the haystack that logging or metrics can miss. Just because your application code is made up of 15 or 20,000 services doesn't mean that the request will travel through each single one of them. At best, it will travel through a fraction of those services. Now back to our previous example of the virtual shop. As you can see, the focused view of a trace can help you immediately ID the problem. In this case, it's the missing key ID. Which key ID though? Looking at the details of the Kafka stream, you see that the username is missing. And now, once you focus on the auth0 microservice, you see why is it missing exactly. It's because of the expired token. So specifically for auth0, you know that now you should be using refresh tokens as the access token has expired. So in short, as you can see, this reduces your mean time to detection and resolution by quite a lot as compared to traditional monitoring solutions. With all this information, you would also want to be able to monitor and alert on different kinds of metrics. Metrics from your own system, from the cloud provider, or from Prometheus. Let's look at some tracing-based solution out there for you to try. There are some open source solutions out there. With distributed tracing, you have frameworks such as Jaeger and Zipkin. Recently, OpenTelemetry has tried to tie these pieces all together. These are the frameworks that are supposed to be utilized and followed. I love the work that the open source community has done with these frameworks. These are helpful in pinpointing the issues, but they do come at a significant development cost. Let's see how one can instrument using OpenTelemetry. So in a distributed tracing application, instrument within your code to create a block of a trace called span. A span represents the work done by a single service with time intervals and associated metadata. you should collect and include in your spans all the relevant information, including payloads in many cases. By injecting and extracting identifiers from spans and API calls, you can correlate spans from remote services as well. So we at Epsagon try to build our solution around these observations and as well as talking to industry experts as well as our customers. So here are some of the best practices that are out there. So the agent should be able to collect the data from any component within your stack, whether it's a service running in the container or function as a service or even traditional VM, while stitching together these transactions through databases and middleware without requiring separate agents. We are able to do this with rich context across metrics, events, logs, and traces, and allow you to search full payload or custom tags. You should be able to analyze data with different viewpoints as well. So in a sense, what we feel is an observability solution should not only tell you that something has gone wrong, but pinpoint to where and why exactly so that it helps reduce your mean time to detection and resolution. Observability should be top of mind for every organization by now, but it shouldn't come at the developer or business velocity. Let's look at some of the benefits of distributed tracing. A typical architecture has a number of microservices involved, and one of the most important features of an observability solution is visualization. Users should also expect actionable data within these complex visualizations and service maps. As we zoom in or filter on specific components, the user should have the ability to start seeing latency between these components, as well as the areas where thresholds have been crossed. Metrics should also be present to provide some context to issues or alerts that are going out. These service maps are also helpful to understand the impact of your chaos experiments. So for example, you can understand the blast radius using these service maps. So when issues are identified in an application, a distributed tracing solution should focus the visualization down to a narrow scope of services. This would help take out the guesswork in determining the impact of an outage or your experiment or where the latency has been seen. Without smart filtering capabilities, an architecture map becomes nothing more than an exercise in chaos theory. Another great benefit of a distributed solution is to pinpoint where time is being spent in the code. Here is an example of spans which make up a trace. So the spans tell us if a significant portion of our time is being spent on an external API call, or whether we have an inefficient database call being made that needs refactoring. At Epsagon, our waterfall visualization can provide you with rich context of metadata to help troubleshoot issues in real time. At a business level, you not only need to look at traffic of our application holistically, which of course is important, but also in the context of each service and component. In this example, we have the payment service that handles our processing, and the traffic there drops to 0. That's a huge problem, even if the traffic in other service of our application is fine. So we need to have the flexibility to slice the data in a number of ways, and a couple of examples are being shown here. We may also want to look at the traffic at an application level, at a service level, or even at a resource type level. It's going to be the same story when it comes to errors. Not all errors are the same. An error that is critical in service A might be ignored in service B. And so again, when it comes to really understanding the error state of your application, you need to look at it from n different viewpoints. Maybe that's breaking it down by error code. For example, a user being rate limited is important information, but it is not as critical as seeing a huge amount of 500s. Furthermore, we want to look at errors based off of not only error codes, but also based out of exception type. So there are n number of ways you would want to visualize, track, and understand errors through your system. And it is the job of a good observability tool to allow you to do just that. Let's see how you can approach observability in your organization. So first of all, you should have clarity on your business goals and architecture experiments that you're supposed to perform. Then you should determine what your approach should be, DIY or managed. Both have their pros and cons. Obviously, you know that DIY solutions such as the open source solutions are free, but they come at a high developer time as well as velocity. So you have to implement observability solutions, and then you do the chaos experiments and use the observability hand in hand to identify the issues and test your hypothesis. The final point is the most critical one. As we know, microservices scale extremely fast. So it is a job of a good observability solution to scale along with the microservices as well. So finally, to summarize this session, we saw that distributed microservices architectures come with their own unique benefits and challenges. Observability through metrics like throughput or simply seeing the response time aren't enough. So we need to go into distributed tracing approach. Distributed tracing with context helps tell the story of when, where, and why a user encountered an error. Finally, observability helps us to get visibility into our architecture, reduce mean time to resolution and detection, and reduce a bunch of costs associated with it. Most importantly, it helps avoid unnecessary chaos engineering efforts. I would like to end the session just by saying that observability should be a critical priority for your organization by now, and it shouldn't come at the expense of business or developer velocity. A great observability solution complements the shift of our mindset that chaos engineering strives for. That is, not being reactive, but being proactive. So thanks a lot for attending the session. Please visit the link displayed here for a special offer. And if you have any questions, please let me know in the Q&A bar.
So we don't have any questions from the attendees. I think you can also send your questions to the Slack channel where Chinmay can answer post the conference too. But if you do have some questions, it'd be better to post now since we have about 10 minutes.
Okay, I guess we can look at the questions in the Slack channel.
Yeah, sure. We just got one. How can an SRE improve the observability for a large website like LinkedIn? It's a question from Rahul.
Okay. So essentially, it boils down to what observability solution you look at, and different observability solutions support different frameworks. So if your website is built on, let's say, Python or Node, then you'll have to find observability solutions that support that framework. The second part is who's your cloud provider? So for example, if AWS is your cloud provider, you need to understand and find an observability solution which can trace through each and every AWS component, including step functions or API gateway, so that you have clear observability for all of these. And then finally, a good observability solution should also pinpoint where issues and errors are occurring and give you some context on that. So that helps the SRE reduce their own time as well as effort. I hope that answers the question. If you have any more questions, I can definitely chat with you on.
Yep. Cyan just posted the link for the Slack channel, and let me also probably post the link for the invite. Okay, I just posted the link. Have some questions, post the talk. You can join the Slack. We have a dedicated session-specific channel over there on Slack for all the sessions. In fact, you can post your questions to Chinmay over there, and we'll have Chinmay answer that.
All right. Thanks, Mohan, for organizing this.
Thank you, Chinmay. Thank you for coming to Chaos Carnival. hoping to see you next year too.
Yeah. All right.